Hi, today we are going to talk about directed graph and how it is implemented into our life. So, the first one, directed graph are like maps that shows how things are connected, and connectedness is a graph that is connected if it has no isolated vertices. Okay, a path is a sequence of vertices in which each adjacent pair is connected by an edge length. A path is a sequence of vertices in which each adjacent pair is connected by an edge. Length is a number of edges. Simple path has no repeated edges and elementary has no repeated vertex. Circuit is a closed path that begins and ends at the same vertex. Simple circuit is a simple, respectively elementary, if there is no repeated edges, respectively vertices. Length is a number of edges, need to be at least 3. Okay, in this presentation there is 6 content. The first one is Eulerian. Eulerian is where it visits every edge of a graph exactly once. The second one is Eulerian circuit. It needs to visit every edges and it need to be odd edges at least 2. And the third one is Eulerian path. It need to visit every edges and close in the same place where it begins, and it needs to have even edges, all even edges. Okay, moving on to Hamiltonian. Hamiltonian is where it visits every vertex exactly 1. And the second one is Hamiltonian circuit. It needs to visit every vertex exactly 1 and need to begins and end at the same place so it close. And the third one is Hamiltonian path. It need to visit every vertex exactly 1 and cannot have isolated vertex.
Example of application in real life of this topic is flight connection. Each airport represents as a vertex in the graph. Directed edges connect airports, indicating that the existence of flight routes. Directed graph also help in finding path for air traveling, ensuring the most efficient path. The graph structure also enables network analysis of the connectivity of airport that helps understanding which airport are linked and which can be reached throughout connecting flights. So let's start with question 1. So is it possible to travel to each city exactly one by taking directed flight? So we talk about visiting exactly once. Is it actually a Hamiltonian path? It means you need to visit each vertex without visiting the previous vertex you already traveled. So like the question say, the traveler begins his journey at A. So we need to start from A, then to B, then to C, then to F, then to H, then to G, then to D, then to E. So we already visited all the vertex once, like the question asks. So there is actually more than one way to solve this question, because the rule is just to visit each vertex once. So you can start from A to B, or you can actually start from A to B to A to D. So question 2. Is it possible to travel to each city exactly once by taking directed flight and come back to the starting city? So from the question, we can identify that this is a question about Hamiltonian circuit, because you want the traveler to visit each vertex exactly once and end the journey where the traveler begins. There's actually multiple ways you can answer this question. One of the answer is actually starting from A, B, C, F, H, G, E, D, then come back to A. This answer shows that we already traveled through all the vertex and stop at the first vertex where it begins.
Now for the next question, to travel to each city by using every routes for Eulerian path. We cannot answer this because we cannot answer this with Eulerian path because there is no odd edges or all edges are even. For Eulerian path, we need to have exactly 2 odd edges to start the path and also end the path, meaning that, for example, A must be in odd number, or H must also be at the end must be odd number. For this question, we can see that A have 2 path, B have 4, C have 2, 4, 2, 4 and also 4, meaning that we cannot do the Eulerian path. For the next question, to travel to each city by using every routes and end at the starting city, Eulerian circuit. meaning that we have to start with A and also end with A, and we cannot go through the same path twice. For this question, we can see that we can go to from point A to B, C, F, H, G, and F, E, G, D, E, B, D, A. We are using the same path twice, so meaning that we can answer this with Elren circle.
So the summary of this presentation is that airports are portrayed as vertices in graph connected by directed edges that indicate flight routes. Directed graph also help in identifying the most effective direction for air travels. The graph structures enable for network analysis and unveiling connectivity patterns between airports and facilitating interpretation, correlations and availability of airports through connecting flights. That's all. Thank you.